This video is over objective 4.3 and it's video part 1. Let's start with a little definition. A quadratic equation may have 0, 1, or 2 real solutions. When graphed, these are the x-intercepts on the graph. So we can see here that if it has one solution, that means the vertex is on the x-axis. If it has two solutions, it means it crosses the x-axis twice. And if it has no solutions, it means that it does not touch the x-axis. There are many ways to solve quadratics. The first method we're going to talk about is taking square roots. This is pretty similar to your traditional method of solving linear equations, in which you just try to get x by itself. This is when you do not have an x term. You just have an x squared term and a constant. You can solve using inverse operations, and the inverse operation of squaring is square rooting. Now, pay really close attention to this little note. You must isolate the squared term. So let's start with example A. Okay, we are trying to get the x squared term by itself. So we're undoing everything that is not the x squared term. So we're going to undo the 5, we're going to undo the negative 7. So what should we start with here? Well, let's undo the minus 7. We undo subtraction by adding. So we're going to add 7 on both sides. That cancels. We need to undo the 5. It's being multiplied, so we're going to divide by 5. 5 cancels, so we're left with x squared equals 16. And then finally the x squared term is by itself. So the only thing we need to undo to get x by itself is the squared. How do we undo squaring? We square root. Now when we solve an equation using a square root, we're going to use a plus or minus. Because here we're asking ourselves what number squared equals 16. Well, it could be positive 4 squared, or it could be negative 4 squared. That's why we put the plus or minus. Let's take a look at B. B is going to be really similar. So we're trying to get the x squared term by itself. So let's start by undoing the plus 5. We undo addition by subtracting. So subtract 5, it cancels. We're left with 3x squared equals 36. Then we're going to undo the 3 by dividing both sides by 3. We're left with x squared equals 12. Now we have to undo the squared, so we're going to square root both sides. And we have x equals plus or minus square root of 12. So here's the thing about you're having an answer that's a square root. You have to make sure that square root is simplified. Square root of 12 is not a nice integer number, so we have to ask ourselves, is the radicand divisible by a perfect square? Think back to your perfect squares we learned earlier in this unit. And 4 goes into 12. So I'm going to do square root of 4 times square root of 3. Square root of 4 is 2, and the 3 gets stuck in. So x equals plus or minus, that's still there, 2 root 3. And that's going to be our answer. Let's take a look at C. Start by undoing the plus 15. We undo addition with subtraction. So we have 2x squared equals negative 80. Then we're going to divide by 2. So we have x squared equals negative 40. And we need to undo the squared. So we take the square root of both sides. We have x equals plus or minus the square root of negative 40. Once again, I have to check to see, can I simplify that? Well, 4 goes into 40. Since it's negative, I'm going to do negative 4 times 10. Square root of negative 4 is 2i, and that 10 gets stuck in. We still have the plus or minus, so x equals plus or minus 2i root 10. Now, up on the number line, or up on the graph, sorry, this plus or minus 2i, Since it's an imaginary number, that tells you that it will not cross the x-axis at all. All right, so here, this should look pretty traditional as we saw for x on all of these. Should look very similar to what you're used to from Algebra 1 and solving for x. Let's go ahead and look at something that looks a little different. All right, example 2a. So remember, on the front, I told you to pay close attention to the note that said that we wanted to solve for the x term. Or I'm sorry, the squared term. So here we have this thing being squared. We're going to solve for this entire thing. So we want to undo that 3. It's being multiplied, so we're going to divide both sides by 3. I'm left with x minus 2 squared equals 9. Now, I'm going to undo that squared part next by square rooting. That cancels off the squared, but I still have that x minus 2. Square root of 9 is 3. Remember, we use plus or minus when we use square root, so plus or minus 3. X still isn't by itself, so how would I undo that minus 2? Well, I would need to add 2 to both sides. So x equals positive 3 plus 2, which is 5, and negative 3 plus 2, which is negative 1. That's what that plus or minus 3 means. It literally translates to positive 3 or negative 3. All right, so let's look at one that's similar to that. Once again, we're trying to get the squared part by itself. We'll have to undo this 5. It's on bottom, which means it's being divided, so I'm going to multiply both sides by 5. That cancels it out, and I'm left with x plus 3 squared equals 35. Then I want to undo the squared, so we're going to square root both sides. Cancels out the squared, so I have x plus 3 equals plus or minus square root of 35. I have to ask myself if the square root of 35 can be simplified. No perfect square goes into 35, so that's as far as we can take it. But x still isn't by itself. We have to undo this plus 3. So we're going to subtract 3. Now, unlike example A, we cannot combine square root of 35 and 3. So we're actually going to leave it either like this, or how you'll typically see it is negative 3 plus or minus root 35. Notation-wise, that second is a better way to write it.